Infinite geometric series. An infinite geometric series is the sum of a geometric sequence with infinitely many terms. Let's consider this first series. If we look for the common ratio, r is equal to 1/2. Now, when the absolute value of the common ratio is less than 1, we say that the infinite sequence converges. The values are going to get smaller and they're going to approach a fixed number as the terms increase. In this case, we say that the infinite geometric series has a sum. Now, if you consider the second series, r, as we get to the next term, is equal to 3. When the absolute value of the common ratio is greater than 1, the infinite sequence diverges. That means the values are getting bigger and they don't approach a fixed number. That means our sum is just going to get bigger and bigger and bigger. So we say that this series does not have a sum. This is the formula to find the sum of an infinite geometric series. Again, we are given this formula on the SOL formula sheet, so you don't need to memorize it. You just need to know how to use it. So we're finding the sum of infinitely many terms. A sub 1 is our first term, and r is our common ratio. And remember, just as a reminder, you can only use this formula to find a sum if the absolute value of that common ratio is less than 1. In this set of examples, we need to determine whether each infinite geometric series diverges or converges. If the series converges, we need to state the sum. So the first thing we need to do in each example is find the common ratio. From the first to the second term, we multiply by a negative 1/6. From the second to the third, we multiply by negative 1/6. And again, from the third to the fourth, we multiply by negative 1/6. Then we need to take a look at the absolute value of that common ratio. So the absolute value of negative 1/6 is 1/6. And then the question is this value smaller than 1 or greater than 1? Positive 1/6 is less than 1, which means that our series is going to converge. So, since it converges, we need to do the second part of the problem, which is to state the sum. So we're going to use our formula given to us. Since the absolute value of r is less than 1, we are going to find the sum of the infinite terms. Our first term, a sub 1, is 1. And then we have 1 minus, we're going to put our common ratio. I'm going to go ahead and write it in parentheses. So then you want to be careful with that because when we have minus and negative, remember that changes to plus or positive. So when you simplify this, we have the sum of the infinitely many terms of this geometric series is going to be 6/7. Now I want you to go ahead and pause, try example 2, and check back with me when you're finished. Now remember, the first step is to find the common ratio, which is 2. The absolute value of 2 is 2, and because 2 is greater than 1, we say that this infinite geometric series diverges and there is no sum. In this set of examples, we need to find the sum of the infinite geometric series. Now, there are actually two formulas that we need to refer to for this. First is you need to remember the formula for the nth term of a geometric series. A sub 1 is that very first number, and r is the one in the parentheses with the exponent. That's important because we're going to need to identify that in example 3 and example 4. So the important information we need is the first term. So 3 is our a sub 1, and then 0.7, this is our common ratio r. Now we're going to use those values to find the sum of the infinite geometric series. So if we are finding the sum of the infinite terms, we need to take the first term, which is 3, and put that over 1 minus the common ratio, which is 0.7. Now we can calculate that, and we will find that the sum of the infinitely many terms of this series is 10. I want you to go ahead and pause, try example 4 on your own, and check back with me when you're finished. Hopefully you found that the sum of the infinite geometric series in example 4 was 16 over 3. If not, pause, check your work with mine, and see where you might have made a mistake. In this last example, we're going to find the common ratio of the infinite geometric series given the following information. We're given that a sub 1 is equal to 4 and that the sum is equal to 10. So if we want to find the ratio, we're going to take that formula for the infinite geometric series and substitute in the values that we know. The sum is going to be 10. We have our first term is 4, and we actually need to solve for r. So what we're going to do here is if you put the left side over 1, now it's like a proportion. I would say put the expression in parentheses, and then we're going to cross multiply. So we're going to get 10 times 1 minus r is equal to 4, and then we're going to go ahead and solve. So if we distribute the 10 minus 10r is equal to 4, subtract the 10 from both sides. Then we have negative 10r is equal to negative 6, and then lastly divide by negative 10. And when you simplify negative 6 over negative 10, we'll have our common ratio is 3/5. I want you to go ahead and try this example on your own and check back with me when you're finished. Hopefully you found that the common ratio was negative 2/9. If not, pause and check your work with mine and see where you might have made a mistake. That's it for our notes on the infinite geometric series.